Hello friends, today we are going to study about the layer 3, the network layer or the IP addressing layer of the OSI layer, correct? So what are the 7 layers of the OSI? Application, presentation, session, transport, network layer and data link layer. And then there is a physical layer. So network layer works at layer 3. What is the data unit at layer 3 called as packet? What is the addressing scheme that works at the layer 3? That is IP address. Now what is the job of the IP? To carry data from one point to another, which is often referred as routing. Of course, the routing is done by the routing protocol. But for routing protocol to do the routing, IP address is needed, correct? So while doing the routing protocol will refer to the fields of the IP addresses. So what is basically an IP? Or how the IP address looks like. So as I said, IP carries data from one point to another point, or from one machine to another machine, or from one subnet to another subnet. Okay. Now, to carry data from one machine to another machine, or one point to another point, you need to have a source address, source IP address, and you need to have a destination IP address. So these are the two compulsory fields that you will see in a IP packet. Now, we have two types of IP addressing scheme nowadays. Earlier it was only IP version 4, but now we have IP version 6 as well. So when a routing protocol selects the IP, it will either select IP version 4 or IP version 6. So how it will come to know that it is using IP version 4 or IP version 6? It will come to know through the field that will mention whether the IP address is a version 4 or a version 6. So this is another field, the version of the IP address. This is an important field, okay, for a routing protocol to understand which type of IP it is transporting. Now, once you are done with the IP version 4, you need to also understand what is the header length. If you are using the IP version 4 or if you are using IP version 6, you need to the header length information has to be carried along with the IP address. So there is one more field called as header length. Okay. And other than this header length, you also need to carry total length. Total length will include length of the data packet, isn't it? So when the data packet is sent from one point to another, this total length will also be calculated and it will be put into one field of the IP addressing of the IP packet. Okay. Now, have you ever seen in a busy street what happens if an ambulance arrives? What happens if an ambulance arrives? The ambulance is given higher priority, correct? Because some critical thing has to be transported. A person is injured or or an accident has happened, so he needs to be transported to hospital immediately, and there cannot be any delay. So the ambulance needs priority. So similarly, in the world of networking, there could be few data packets which needs to be handled at a higher priority. Why? Because if you delay, then probably the information that is carried by the packet will become useless due to the delay. Now, what kind of packets requires less delay or zero delay, okay, or sensitive to delay? So those are voice and video packets. Voice and video packets are sensitive to delay, isn't it? If suppose delay. If suppose a person at point A says hi, and the person who is listening on the other end, hi, how, if he says hi, how are you, and if the person on the other end experience lot of delay, so probably the message hi, how are you may not be in the same format. It will be like you are, how, hi, like that. The message will reach to the other side, and it will not make any sense. Probably it will be a garbled message. So sometimes the data packet needs to be given, certain data packet needs to be given higher priority. Okay, if you remember the transport layer, we have discussed about TCP and UDP, isn't it? So what is TCP? TCP, what is the function of TCP? So TCP basically helps in error recovery or and work and flow and control the flow of the data. So how does the TCP do the error recovery? By sending a SYN packet and expecting an acknowledgement packet. But suppose if you have a voice or video, if you send, suppose if you send hi, how are you, okay, a hi goes and then it requires an acknowledgement for that hi packet. Then how goes and then it requires an acknowledgement for that packet. So is it will this kind of error recovery helpful for a voice packet or a video packet? No, you cannot wait for an acknowledgement. Correct. So most of the voice and video packet works at UDP. Correct. So TCP and UDP are what? They are the higher level protocol, isn't it? They are layer 4. So that has to be embedded in your IP address. So you need that information, what protocol, what transport protocol it is carrying. TCP IP address, IP packet is carrying. Is it a TCP or is it a UDP or is it any other protocol like S.323 or anything like voice video? So that information is needed. Correct. Now imagine you have, especially in Bangalore or in Pune or Mumbai city, when a person comes from the outside state, from the different state, what he does, he will order a transport vehicle to carry his luggage, isn't it? From one state to another. So what that the luggage guy, the one who is going to carry the luggage, what he will do, he will bring few people at your house and they will pack up everything. They will mark each and every luggage and they'll put it inside the truck. Okay, and suppose they will mark like, okay, there are 10 pieces. So when this luggage reaches to the other side, to the destination, it should carry 10 pieces, isn't it? Similarly, if IP header, if a IP packet is carrying certain information, that information should remain intact at the other side also. Correct. So that's why for that we have a header checksum. Basically, this will only calculate your header part, not the entire data, but it does the same thing. Okay, it will calculate the some number based on the header length, okay, or the header information, and it will put that number in the packet. When the packet reaches the destination, it will again, the destination router or the machine will again calculate the checksum. If it is same, that means the IP header is not been tampered with, so the integrity is maintained. Okay, so what basically when you say integrity means what? When you are sending a data or any information, it should not be tampered in the middle or during the transit. That is what is integrity. Okay, you will often hear two like 3-4 words in the networking security or in the data security, that is confidentiality, availability, integrity. So CIA triad, you will often hear this: confidentiality, integrity, availability. So integrity is one part of the security. So that is taken care by the header checksum. Okay, now as I told you that there are 10 packets. Okay, so probably that guy will mark, suppose there are 10 packets. Now suppose you have a big sofa. You want to carry a big sofa, and that sofa does not fit into your truck. Directly you cannot put it inside your truck. Okay, okay. So what that guy will do? He will deassemble that entire sofa, and he will put that sofa in. He will convert that sofa into few pieces, and then he will put it into the truck. Again, when the truck reaches the destination, he will again reassemble everything. Okay. So same thing happens with your IP packet. If the packet is too large, okay, then what will happen? The packet will be fragmented. So there is a field, there is a flag inside IP headers called as more fragment. If it is set, that means the packets will be fragmented. Okay. But suppose the sofa is like you cannot. There is no way that you can break it into pieces. Okay, it's made from one single solid wood. So what, you cannot fragment it, right? You cannot break it. So there is also a flag in IP address. If suppose the application demands that the the data should not be fragmented. So there is a flag called don't fragment. Okay. Now you understood what is don't fragment, more fragment. Now suppose this truck is carrying a big piece of an art. Okay. Now that big piece was not able to fit into the truck. So what that guy has done, he has broken it into 6 or 8 pieces. Okay. And he has marked each piece. This is the number 1, this is number 2, and this is, when it goes to the other side, the guy who will receive it will have to assemble it in the same order. Correct? So that numbering has to be there. Similarly, when a packet reaches the other side, it is quite possible that the single message is divided into multiple fragments, and those fragments needs to be reassembled at the receiving end properly in the same order. So that is done with the help of fragment offset. What it is called as fragment offset. So basically fragment offset what it will say, okay, this packet has been fragmented at such a point, at this point. From this point to another point, there will be another fragment. Okay, so using the fragment offset, more fragment, the packet is reassembled at the other end. So these are the 3 important flags of the IP address. Now I told you about priority of the data, right? If voice has to be given more priority as compared to other applications. So how does that priority is given to that packet? So there is another field for that, we call it as type of service. So when these bits are set, that means that packet has to be given more priority. This is what we call as QoS, quality of service. And inside the IP packet, that field is called as type of service. So quality of service is a big topic, and we will cover it later as we will proceed. Okay, so as of now you need to understand that type of service is a field in the IP packet which will carry the information about the quality of service the packet has to receive. Okay, now what else? What else the IP address contains? Now this packet is there in the network. Suppose for some reason it is not able to reach the destination. So should that packet remain alive forever in your network? Should it keep on going on and on and on from one hop to another hop like that? No, right? It has to have a certain life. After that, it should expire. Otherwise, your it will consume all the bandwidth of your network. Suppose there are 100 or 1,000 such packets which are alive on the network, they will consume the bandwidth and it will cause congestion. It will slow down your network. Correct? So for that, we have a TTL, time to live. So every packet is marked with a time to live information. How long it can live on the network. What is the life of that packet? So that is time to live. So these are the different fields of a IP address which is needed for IP for a routing protocol to do the routing of the IP packet. Okay, not IP address, but the IP packet. IP address is how you do the addressing to, how you provide an IP address to a particular device. It's a separate topic and we will cover it in a different session. Today we will just understand what is an IP packet. Okay, what is an IP packet? So let's see how the IP packet actually looks like. What is the max size of the packet? 20 byte is the header length of the IP packet. IP header is the length of IP header. So whenever someone asks you about the IP packet or the different fields of the IP packet, if you understand it logically, okay, then you will be able to immediately answer all the different fields of the IP packet. Okay. So let's understand how the IP packet. So this is how the IP packet looks like. Let me put it in the presentation mode. Okay. This is how your IP packet looks like. So it has the version, as I told you. Okay. Then it has a header length. It has a type of service, total length, don't fragment bit, more fragment offset. Then you have a time to live. Then the higher level protocol like TCP or UDP. Okay, header checksum. Then source IP address, destination IP address. Now, what is this identification packet? As I told you, when you are sending a big painting or a big painting in a truck, which cannot be fragmented, so, or which needs to be fragmented. So what it will do, the identification will identify the packets. So identification along with the help of DF, don't fragment, more fragment and fragment offset, will reassemble the packet at the destination end. Okay. So this is all about the IP address. So the questions which can be asked in the interview related to IP, they can ask you how the packet reassembly happens at the destination side. Okay, so basically they are asking, do you know the mechanism of how the DF, more fragment offset and identification works? Do you know these are the fields of the IP address? So that is what they want to know. They will ask you how the voice traffic is treated. So they are basically asking you about the type of service. Do you know about, there is a field called type of service in the IP header? That's what they are asking. Okay, that's enough for today. Enough of information regarding IP packet. Thank you. Bye. Please don't forget to subscribe and like my channel.